Just imagine, you're using your phone's navigation to find the best kebab shop in town. You type in the address, and a friendly voice tells you where to go. Pretty everyday, right? But what if I told you that this little technical gadget only works because a wild-haired, rebellious thinker turned the entire universe upside down over 100 years ago? And that without his theory, your GPS would be completely useless within minutes? That's exactly what we're talking about today. We're diving into one of the craziest, but also most brilliant ideas in human history, Albert Einstein's theory of relativity. So, buckle up, because we're about to travel through space and time at the speed of light. Before our story's hero, Albert Einstein, entered the stage, the world of physics was, well, pretty tidy. The top dog for over 200 years had been Sir Isaac Newton. His world was like a giant clockwork, predictable, logical, and absolute. Space was a stationary stage, and time was a universal pacemaker that ticked at the exact same speed for everyone in the cosmos. A second on Earth was a second on Jupiter, and a second in the farthest corner of the universe. And gravity? For Newton, that was a mysterious force that makes apples fall from trees and planets orbit the sun, a kind of invisible rubber band that acts instantly and over any distance. But there was a problem, a small, annoying detail that didn't fit the picture. Light. It was thought at the time that light waves needed some kind of medium to travel through, just as sound waves need air. They called this medium the ether. The only problem was, nobody could find this damned ether, no matter how hard they looked. Physics was in a bit of a crisis. And then he came along. Albert Einstein. Not a venerable professor in an ivory tower, but a young man sitting in the patent office in Bern, pondering other people's inventions. But in his head, he was pondering the universe. Einstein wasn't a classic lab scientist. He was a thought experimenter. His superpower was his imagination. He asked himself questions like, what would I see if I were riding on a beam of light? In 1905, his personal miracle year, he published an idea that changed everything, the special theory of relativity. And it's based on two brilliantly simple yet radical assumptions. First, the laws of physics are the same for everyone who is moving uniformly. Logical. But second, and this is the kicker, the speed of light in a vacuum is always and absolutely constant for every observer. Wait, that doesn't sound so wild at first, but think about it. If you're on a train going 100 km/h and you throw a ball forward at 20 km/h, then for someone on the platform, the ball is going 120 km/h. Sure. But if you turn on a flashlight on the same train, the light is exactly the same speed for you and for the person on the platform, just under 300,000 kilometers per second. The light doesn't get faster. How can that be? Einstein realized, if the speed, which is distance over time, has to remain constant, then distance and time themselves must change. And this is where it gets crazy. For a fast observer, time passes more slowly. This is called time dilation. An astronaut who whizzes through space at near the speed of light and returns after a year would have aged only 1 year, while on Earth, decades might have passed. His clock ran slower. At the same time, objects shrink in the direction of motion. This is length contraction. The faster you are, the shorter and slower you become for the rest of the world. So space and time are not absolute, they are relative. They depend on the observer. Einstein wove them together into a new, four-dimensional structure, spacetime. But there was still a catch. This theory worked great, but it ignored Newton's old nemesis, gravity. Einstein's special theory of relativity and Newton's gravity didn't fit together. That bugged him. For 10 years, he pondered, calculated, and despaired. He exchanged ideas with colleagues like the mathematician Marcel Grossmann, without whom he would have hardly mastered the complex mathematics. And then, one day, he had what he himself called the happiest thought of his life. He imagined a painter falling from a roof. And he realized, while this painter is falling, he doesn't feel his own weight. He is weightless. For him, in that moment, there is no gravity. So what if gravity isn't a force that pulls us down at all? That was the birth of the general theory of relativity. And the idea is almost insurpassably elegant. Imagine a stretched rubber sheet. That's spacetime. Now, if you place a heavy bowling ball in the middle, What happens? The sheet curves, it gets a dent. If you now place a small marble on the edge, it doesn't roll towards the ball because the ball is attracting it, but because it is following the curvature in the sheet. And that's exactly what gravity is. Massive objects like the sun curve the space-time around them, and planets like Earth are simply moving on the straightest possible path through this curved space-time, which looks to us like an orbit. So, gravity isn't a mysterious force, but the geometry of the universe itself. Mass tells space-time how to curve, and curved space-time tells mass how to move. Even light follows this curvature. This was a theory so bold that many considered it crazy, until 1919. That year, the astronomer Arthur Eddington traveled to Africa during a solar eclipse and photographed the stars right next to the darkened sun. And indeed, their positions in the sky were shifted. The light from these stars was bent by the sun's mass on its way to Earth, exactly as Einstein had predicted. From then on, Albert Einstein was a superstar, the first pop star of science. His face was world famous. The consequences of his theory are gigantic. It allowed us to understand the Big Bang, predict black holes, and detect gravitational waves, tiny ripples in space-time that were only directly measured in 2015. And yes, it's in your GPS. The satellites in orbit move very fast and are in a weaker gravitational field. Their clocks, therefore, run about 38 microseconds faster per day than ours down here. Sounds like nothing, but without the correction from Einstein's formulas, your navigation would send you more than 10 kilometers into the middle of nowhere after just one day. Einstein gave us a new universe, no longer a rigid clockwork, but a dynamic, bizarre, and fascinating entity in which space and time are malleable actors, and gravity is the quiet melody of geometry. He showed us that reality is often much stranger and more wonderful than our everyday experience would have us believe. Phew, that's a lot of stuff, right? If your brain has now experienced a curvature as strong as space-time around a black hole, then I've done everything right. If you enjoyed this little journey through Einstein's thoughts, then give a thumbs up and subscribe to the channel so you don't miss any more cosmic adventures. And now I'm curious. What about the theory of relativity blows your mind the most? Write it in the comments. See you in the next video. Stay curious.